Okay, so we are in lesson 2 in module 10. We are on page 345. Erin plans to make origami cranes, which can be folded into square pieces of paper. So we've got squares. All the sides are the same length. He started by drawing small squares with sides lengths 1, 1, 1, 1. And then we have 2, 2, 2, 2. And then we'll pretend that this is 3, but oh, that was horrible. 3 and 3. Awesome. Oh, and then I have to do 4. Okay, so 4, 4. Awesome. So find the area. So area is equal to base times height. Or, because it's a square, it's side squared. So side squared, 1. Side squared, 4, 9, 16. Because all we did was take 1 times 1, 2 times 2, 3 times 3, and 4 times 4. And these are inches, so it's going to be inches squared, inches squared, inches squared, and inches squared. Okay. Erin is also planning on to make origami cubes of different sizes. The edge, did I mess up on this? Crane by folded square pieces of paper. No, I did okay. Okay, we're using the same thing. Talk to the partner, then write down the formula to determine the volume of the cube. So, area is side squared. If we're doing volume, we do side cubed. So, if I have 1 times 1 times 1, what would I get? I would get 1. If I had 2 times 2 times 2, I would get 8. 3 times 3 times 3, 27. And 4 times 4 times 4. We would get 64. You take the side measure and cube it. If you are given the volume of a cube, how can you find what is multiplied by itself 3 times? What is the edge length of a cube who has a volume? So the volume is 125 cubic inches. Why is it difficult to express the edge length of a cube with the volume of 10? Okay, so we have to find. So we know that 4 cubed is 64. So what's 5 cubed? 5 times 5 times 5. 5 times 5 is 25. 25 times 5 is 125. Oh, that's easy. So this is the same thing as 5 times 5 times 5. So that means the side length is equal to 5 inches. Now, if I have the volume is 10 cubic inches, what times itself 3 times is going to get 10. So why is it difficult? There isn't a whole number multiplied by itself to get 10. Okay. So the square root. Square root of a positive number p, is when x squared is equal to p. Note that every positive number has 2 square roots. For example, 3 squared is 9, and in parentheses, -3 squared is 9. So the roots, the answers are 3 and -3. It can also be written positive and -3, or plus and minus 3. A perfect square is a whole number whose square roots are integers. Okay, so 16's perfect square are 4 and -4. The square root of any number that isn't a perfect square is an irrational number. This symbol is called a radical symbol. It is used to indicate the positive square root or the principal square root of a number. So the square root of 16 equals 4. Okay, so here we go. What squared gets 81? So 9 times itself gets 81. What else gets 81? -9 squared gets 81. So the square root, so if I was going backwards, 9 and -9 would be the square roots. Okay, if I look at this, I have what times what gets 4? That's 2. What times what gets 9? 3. Then the negative of that also, all squared, would get us 4/9. So the square root symbol indicates the principal square root. So 2/3. Suppose Aaron wants a square piece of origami paper with an area of 2 square centimeters. What is the length of one side of the piece of paper? Use a square root symbol in your answer. The square root of 2. Is 2 a perfect square? No. There is not an integer whose square is 2. Nothing times itself gets 2. Is the square root of 2 rational or irrational? It is irrational. It cannot be written as a ratio of 2 integers. Okay, a cubed root of a positive number, p, is x when x cubed equals p. For every positive number has 1 cubed root. For example, 4 cubed is 64. The cubed root, so going the opposite way, the cubed root of 64 is 4. So let's look at this. And a perfect cube is a whole number whose cube root is an integer. Okay, so let's look at this. Find the cubed root of 8/27. So what times itself 3 times will get 8? 2 times 2 times 2 gets 8. So didn't mean to write that. What times itself 3 times gets 27? 3 times 3 times 3. So 2/3 cubed is equal to 8/27. So if I'm going backwards and I'm given the 8 over 27 and I want to find the cubed root, it would be 2/3. You can write it as the cubed root of 8 over 27 is equal to 2/3. Okay. Says, what is the side length of a square picture frame? Okay, so x squared equals 100. If I take the square root of both sides of the equal sign, I'm going to get x equals plus or minus the square root of 100. That would be 10. Now, the side length of the picture frame is 10 inches. Why is it not the negative? Because it's not possible for the length in the real world to be a negative number. Okay, so here. The cubed root of, y to the third equals 1 over 14. If I take the cubed root of both sides, we get y, and then we get the cubed root of 1 over 14. Since no rational number, when cubed, equals 1 over 14, the cubed root of 1 over 14 represents the solution to that. Okay, so we're going to go down here. If I take the square root of both sides of this, it is going to be plus or minus the square root of 7. Okay? When I do the cubed root, there's only one answer. 1 times 1 times 1 will get, oops, I forgot the cubed, sorry. What times itself gets 64? 4. So the cubed root of 1 over 64 is 1/4. Now down here, we don't have an x squared involved, so we're just talking about the principal square root. So what times itself gets 121? 11. What times itself gets 16? 4. What times itself gets 25? 5. Well, then we have here. What times itself 3 times gets 125? Not 25, Kim. How about 5? 5 times 5 gets 25. 25 times 5 gets 125. Okay. A band stores its equipment in a large cube. The cube has sound dampening foam designed to allow the drummer to play inside the cube when the band is practicing, like that. Okay, is 125 a perfect cube? Yes, because 5 times 5 times 5 is 125. What is the edge length of the cube? I just kind of explained that, didn't I? Find the square root. The square roots of, so x squared equals 400. If I was to take the square root of that, of both sides, I would get x equals plus or minus. What times itself will get 400? Well, we know 2 times 2 will get us 4. 10 times 10 will get us 100. What about 20 times 20? What will that get us? That'll get us 400. So plus or minus 20. Find the cubed root of 8 over 125. Show how you can check that you found the right, okay? So the cubed root of 8 over 125. That equals the cubed root of saying 2 times 2 times 2 over 5 times 5 times 5. So that means this is the cubed root of 2 to the third power over 5 to the third power. So that would get us 2 over 5. A student claimed 7 and -7 are the two cubed roots of 348. Do you agree? Well, 7 times 7 times 7, would that equal 343? Well, let's see. This is 49. 49 times 7. Yes, that one would work. What about if I had -7 times -7 times -7? This would get me 49 times -7. That would equal -343. So no. Solve. So 196. Well, 10 squared equals 100. 11 squared equals 121. 12 squared equals 144. 13 squared equals 169. 14 squared equals 196. So if I was to take the square root of both sides, I would get x equals plus or minus 14. Okay? Show your work for these steps. Okay? So 2 cubed equals 8. 3 cubed equals 27. 4 cubed equals 64. 5 cubed, 5 times 5 times 5 is 125. 6 cubed would get 36 times 6. That gets 6. That's 3. That's 8, 18, 20, 21. Oh, 216. Look at that. So if I cube root both sides of this, what times itself 3 times gets 125? We have that right there. It's 5. And 216 is right there. It's 6. So my answer is 5/6. A square tile has the area of less than 1 square foot. The area and length are rational numbers. What is the possible area of the tile of the square feet? Okay. So the area of less than 1 square foot and the length of the are rational numbers. Okay. So that means the area is less than 1. So, I don't know, 9/16. Is that less than 1? Okay. The area and the length are rational numbers. So I square root that, I get 3 over 4. What is a possible area for the tile length? Okay, 9/16 inches, feet squared, and corresponding side, 3/4 feet. What do the perfect squares have in common? 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144. What do you notice about the ones digit and each of the perfect squares? The ones digit, 1, 4, 9, 6, 5, 6, 9, 4, 0. I don't actually know. That's a very good question. One, 4, 9. 1. There's no 2. Oh, no. There's no 2. No, there's no 3. There's no, there's a 4. There's a 5. There's a 6. There's no 7. There is a 9. There is a 0. Okay. It ends in a 2. So I'm going to say no. Nothing times itself will have a 2 in the ones column. Look at this. 1, 1, 4, 4. Interesting. Okay, I've never noticed that. Does the square root of 0 exist? Yes, because 0 times 0 equals 0, and 0 times 0 times 0 equals 0. Okay, find the roots. $225. Well, let's see. 10 squared equals 100. 11 squared equals, oh, we just did these up above. So I just need to go above 12. So 13 squared is 169. 14 squared is 196. 15 squared is equal to 225. So this would be 15. Ooh, 729. 5 squared equals 125. 6 squared is 216. Squared, I meant cubed, equals 343. I can't do 8 off the top of my head. So that's going to be 64 times 8. That'll get us 512. 9 squared. 9 cubed. So 81 times 9 equals, oh, look at that, 729. It would be 9. This says 64. So 4 cubed is 64. So that's going to get 4 over 7. This one, if I take the square root of both sides, I'm going to get plus or minus. Square root of 1 is 1. The square root of 49 is 7. The cubed root, there's only one answer to that, and it would be n equals the cubed root of 19. Over here, I'm going to take the cubed root. I get y equals, what times itself gets 27? 3. What times itself gets 125? Oops. 5, so 5/3. Awesome. Okay.